Hello everyone. We are going to be learning backtracking in this day 13 learning of DSA Made easy. So sometimes in an algorithm we might need to try all possibilities, and that is the only way, and backtracking is one such algorithmic practice where we perform all the tries and return back to a previous decision point, right? So we we use recursion here, and it is similar where we keep uh, checking on a specific decision point and we try all the options. Like, let's say we start at a specific point and we try option A, and if this works, then okay. Else, if it is dead zone, then we return back here and try another option. So another option B, and if this is okay, then again we are fine, we return back. Else, if this doesn't work, not good, then again try another case. So if none of these options work, then we return to the starting point, saying that now all of the backtracking options are explored and none works, and therefore we do not have a solution. Even though this is a costly, time taking approach, this would be an ideal or more feasible one in certain problems, right? So yeah, it's like a brute force approach where we start with a specific starting point, and then we explore all the options from there, and we backtrack to a previous decision point. So yeah, that's about backtracking. But let's take up an example and let's understand backtracking better, right? So for this, uh, I have taken up one example of generate all subsequences. So I have taken one example where we are required to generate all subsequences, all subsequence from in, let's say, A, B, C. The expected output will be, so so the idea or the backtracking approach, that the algorithm that I am going to show you in a JSBin editor in few minutes is, uh, first we start at an empty string with an empty input. Then uh, we consider two cases. One is we either skip the next character and take the next character, which is A, right? So with taking A, we again end up with skipping, we end up with empty character, and again we consider two cases: skip B, and we end up here, and take B, that is the next character. Again here we have two cases: skip B and take B. So we end up with, when we skip B, we end up with only the selected character A, and when we take B, it would be AB, right? Here, uh, skip B, we would still be ending up with the same empty character which we started out with. And if we take B, then we end up with this character here. And here, we skip C and take C. Similarly, here, we skip C, take C. So this would be B, and this would be B and C, and here we have skip C and take C. Take C, so this would give us A and AC, right? So with this one also we have skip C and take C. So if you see, we have three different layers. Like one where we have chosen A. Secondly, we have considered the skip B or take B, and here we have skip C or take C, right? Take C. So this would give us AB and ABC. So here we end up with AC. Okay, so these are the set of output that we are expecting with this backtracking algorithm. I will show you the implementation. Just understand the way that backtracking is a general structure of backtracking is done. Then we will again come back to the board and make this concept much more stronger, right? At the first time, if you are first time going through backtracking, it would be a bit more tricky to understand the entire steps as the input grows, but just try to understand the outline or the kind of structure of how a backtracking algorithm would be implemented. That would make it easier, right? So yeah, so here I have already added the code for a generation of all the subsequences with an input str, and this is the backtracking algorithm or the recursive function. So the main pieces that go about this function is with respect to this base case, where we are checking if uh, the value of position has reached the string length. That is, uh, once we keep our, I will again switch back to the drawing board where we had. So we considered skip A, skip B. So here this would be position 1. This would be position 0. And this would be position 2. And this would be position 3. Right? So in this base case, what we have done is, if the position value reaches the string length or the input string length, then we simply push the specific character that we have come across, either taking it or skipping it. Then we return from this entire uh, function. And the two cases that we have asked the recursion to do is with respect to including the character or skipping the character. With inclusion of the character, we have added the character with which the function is invoked, and with exclusion we have just called the input character. With inclusion, we have also called the next character, that is uh, that is the one plus the character, the position that we are looking for, like the one character ahead of it, right? So that's the whole structure of this recursive function that we have here, and the starting point for this recursion would be an zeroth position with an empty character. And if you see, we uh, we had this zeroth position with an empty character, and as we move ahead with three positions, as the input was abc, and we skipped all of the characters, so we also ended up with this empty character, and inclusion of a specific character with a also gave us a, b, and c. And the next set of takes with the combinations of a, b, ac, and bc also are being seen, right? AC, AB, right? These are also seen with the final input string that we have. Hope you found this video helpful, and I would also like to add in the general recursive function structure that we have. Uh, we get, right. So general recursive function structure. So uh, we might have a function, say backtrack, or any custom function that we have, and some params for this function. And if a specific goal is reached, then with a state we record the state, and we capture this output of state, and we also return saying that this is a this is a working piece. And if not, we try with other options with choices, like either inclusion of a specific character or exclusion of a specific character, and then we also backtrack with to a specific state, previous state. So this would be a general uh, template or a structure of a backtracking recursive solution, right? So we will have this base case, and we will have this set of piece of function code where we will try other set of options, or we will backtrack to a previous state, right? So yeah, this would be a thing. uh, we shall complete this video by looking at the time and space complexity of the solution that we had in JSBin. So if you see, the time and space complexity of the solution would be n into 2 power n, right? So n would be the length of the string, and the recursion depth is the number of times we call this function, right? The build sequence function. We call this 2 power n times. And if you remember, we drew out this uh, pyramid like structure, which we also drew out this pyramid like structure where, let me go back to drawing board. Yeah, we drew out this pyramid like structure where we started at position 0, 1, 2, 3. So this is like at 2 power 0, this is only 1, and 2 power 1, 2, and 2 power 2, and 2 power 3. So these are the number of steps that is being taken, and 2 power n is the 2 power n into n is the time complexity and also the space complexity, since recursion has to take up some stack memory when computing, right? So as you see, 2 n into 2 power n because we are creating the number of n number of recursion trees, and also 2 power n for each string we either take or exclude with 2 power n times. So O of n would be the recursion time. Hope you understood the time and space complexity. uh, in the next video we are going to be solving another example with backtracking to solidify or to see the real benefits of backtracking algorithm. Hope you found this video helpful. Please do like and subscribe to